Howdy, Ags! In this mini lecture, we will explore energy efficiency and energy conservation. The student learning objectives of this mini lecture are distinguish between and give examples of energy efficiency and energy conservation, explain how cogeneration can be used to save energy, compare the fuel efficiencies of hybrids and conventional automobiles, describe Obama's fuel economy standards of 2009 and their estimated impacts, and list ways we can reduce and stabilize emissions. For many reasons, mostly related to either our health or the health of the planet, we need to minimize and extend the use of dwindling fossil fuel supplies. We can achieve this by a combination of energy efficiency and energy conservation. Energy efficiency is obtaining a given amount of output while using less energy input. Considering a good deal of energy is lost as waste, we can use technological improvements to improve energy efficiency. An example of energy efficiency would be to use light-emitting diode (LED) or compact fluorescent lights (CFLs) in place of standard fluorescent light bulbs. Energy conservation is quite simply reducing energy use. Energy conservation results from behavioral choices. An example of energy conservation would be to turn off all the lights in a building when it closes. Being less wasteful and prolonging the fossil fuel supply, we can avoid some difficult energy decisions. The United States uses twice as much energy per dollar of gross domestic product as most other industrial nations. Not surprisingly, Europeans use less energy per capita than the United States. We have cut energy use, but there is room for gains in efficiency in the future. Individuals can make conscious choices by driving less, turning off lights, and buying energy-efficient appliances. We as individuals can conserve energy through our personal choices of how we use energy and by using efficient technologies. For example, energy-consuming devices can be made more efficient. Power plants can lose up to 2/3 of energy as waste heat. This waste can be reduced with cogeneration, which is using excess heat from electricity generation to heat nearby buildings and produce other kinds of power. Cogeneration can nearly double the energy efficiency of a power plant. Improvements can also be made to reduce the energy needed to heat and cool homes. In this slide, you see a thermal image that shows the heat loss from homes. The red-colored home indicates that heat is being lost from the house, while the greenhouses are houses that have better insulation that allows the homes to conserve heat and not let it escape. Notice the heat loss for all the houses is greatest around the doors and windows. Vegetation around a home as well as passive solar energy can also conserve energy in a home. Passive solar is when buildings are designed to maximize absorption of sunlight, and thus natural heat, during the winter and to keep the interior cool in the summer. We will discuss passive solar more when we study new renewable energy alternatives. Many consumer products are now more efficient. Energy-efficient lighting can reduce energy use by 80%. Many governments are phasing out incandescent light bulbs in favor of more energy-efficient compact fluorescent bulbs. Federal standards in the Energy Star program have reduced electricity used by appliances. If all Americans bought energy-efficient appliances, energy expenditures would be reduced by $200 billion. Automobiles provide the greatest fossil fuel conservation opportunity because conventional automobiles are very fuel inefficient. Of all the energy and the gas put into the car, only about 13 to 14% actually moves a typical car forward. Nearly 85% of the useful energy is lost, primarily as heat. Alternative technologies such as electric cars, hybrids, and hydrogen fuel cell vehicles are more efficient options than traditional cars. According to the U.S. Energy Information Administration's last annual energy review, the transportation industry consumes 71% of all the petroleum resources in the U.S. and is the second largest energy-using sector, behind only electric power generation. These facts about energy inefficiency of traditional vehicles make it clear that automobile fuel efficiency is a key place where we can conserve energy. Hybrid cars have high fuel efficiencies. Some of the top U.S. hybrid models are the Toyota Prius, the Chevrolet Volt, and the Ford C-Max. Top models of electric vehicles include the Chevrolet Spark EV and the Fiat 500e. The Ford C-Max gets an estimated 42 miles per gallon, or MPG, in the city and 37 on the highway. The Prius gets an estimated 51 miles to the gallon in the city and 49 on the highway. The Chevy Volt gets approximately 42 miles to the gallon. Compare this to a Ford Focus, which is a conventional car, which only gets 26 miles to the gallon. We have a history of attempting, and in some cases succeeding, at obtaining greater energy efficiency in vehicles. In 1973, the Organization of Petroleum Exporting Countries, OPEC, stopped selling oil to the U.S. OPEC is largely run by Arab nations, and most Arab nations opposed the support the U.S. provided to Israel during the Arab-Israeli Yom Kippur War. In response to this embargo, the U.S. government tried to reduce gasoline use by mandating an increase in fuel efficiency and decreasing speed limits to 55 miles per hour. The measures worked, reducing our dependency on foreign oil and our greenhouse gas emissions. However, these conservation initiatives were abandoned over the next 30 years as market forces supported lax policy with fuel use. Essentially, people lacked the economic incentive to conserve fuel because gas prices dropped. Subsequently, speed limits rose, research for alternative energy sources fell, and policymakers failed to raise the corporate average fuel efficiency (CAFE) standards, which set miles per gallon standards. New vehicle average efficiency fell from 22 miles per gallon in 1987 to 19.3 miles per gallon in 2004. MPG standards climbed to 22.8 miles per gallon in 2011 after Congress mandated average fuel economy of 35 miles per gallon by 2020. In 2009, the Obama administration tried to improve fuel efficiency, stimulate economic activity, and save jobs by enacting a program that would work together with automakers to boost average fuel economies to 54.5 miles per gallon by 2025. It is estimated that this program would save consumers $1.7 trillion at the pump over the life of the program, and that a family could save $8,200 in fuel costs compared to a vehicle that did not meet the fuel economy standards set for 2025. Over the life of the program, Obama's fuel economy standards are estimated to save 12 billion barrels of oil and eliminate 6 billion metric tons of CO2 pollution. Here is a graph that shows what the MPG standards for vehicles has been historically and what it will be as the Obama fuel economy standards are phased in. Please note that the technologies already exist to meet these fuel standards. It's just a question of whether or not the automobile industry is motivated, financially or otherwise, to put this technology in place for the fleet of vehicles they produce each year. All the science about the impact of burning fossil fuels and the relative abundance of this limited resource indicates that we need to drastically reduce our emissions from fossil fuel combustion. While this seems like a daunting task, if we break it up into smaller steps, it is much more manageable. Here you see a figure that shows 15 strategies that will each eliminate 1 billion tons of carbon each year by 2050 if deployed at a large scale. If we achieve just 7 of these 15, we would stabilize our emissions. If we achieve more, we will reduce our emissions. Some of the actions listed here are to double the fuel economy of cars, which compared to MPGs of 1970, we will achieve with Obama's fuel economy standards of 2025, cut the miles driven by cars in half, maximize efficiency of all buildings, this is where LEED certifications will come in, double the efficiency of coal-powered plants, cogeneration can help achieve this, switch from coal to natural gas at 1,400 plants, natural gas is cleaner burning than coal, capture and store carbon from 800 coal plants. This is referred to carbon capture and carbon storage or carbon sequestration. Carbon capture consists of capturing CO2 emissions, converting the gas to a liquid, and then sequestering, that is storing, the liquid in the ocean or in underground geological formations. Capture and store carbon from 180 synfuel plants, triple the world's nuclear capacity and increase ethanol production by 50 times. We will discuss nuclear energy and ethanol when we discuss conventional energy alternatives. Increase hydrogen fuel production 10 times and increase wind and solar capacity by 50 and 700 times, respectively. We will examine these energy sources when we discuss new renewable energy alternatives. Halt tropical deforestation and double reforestation efforts, and adopt conservation tillage on all croplands. I hope this last topic leaves you on a slightly positive note. There are things we can do to fix the problems we have created for ourselves, and the good news is we currently have the technology we need to make these changes. The question is more of a matter of will. You can make a difference, and as you proceed through your life, you can help to solve this problem through the choices you make and the policies you support. That concludes this mini lecture on energy efficiency and conservation. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!